And what if I told you there's a real chance that your entire life, all your feelings, memories, and experiences are just code running on an alien computer? That every atom, every star, every galaxy we observe might be nothing more than information processed in a cosmic simulation. It sounds like sci-fi, but some of the world's greatest physicists and philosophers take this possibility very seriously, and the evidence they've found will make you question the very nature of reality. Today, we're re-diving into one of modern science's most unsettling and fascinating ideas, the simulated reality hypothesis. We'll explore philosopher Nick Bostrom's revolutionary proposal, uncover the intriguing clues physicists have already found in our universe, and learn about the surprising methods scientists are developing to test whether or not we live in a simulation. Get ready for a journey that could forever change how you see the world around you. Welcome, Cosmic Explorers. This is the Cosmic Frontiers channel, where we unravel the mysteries of the universe together. We're on an incredible journey towards 1,000 cosmic explorers, and every discovery brings us closer to that extraordinary goal. Imagine you're playing a super realistic video game. The graphics are so perfect you can't tell them apart from reality. The characters have consciousness, feelings, complete memories of their lives. They don't know they're simulated to them. That digital world is completely real. Now imagine our technology evolves so much that we can create entire civilizations inside computers, with billions of conscious beings living their lives without ever suspecting they're simulated. This is the basis of the simulated reality hypothesis. In 2003, philosopher Nick Bostrom from Oxford University published a paper that would shake the foundations of philosophy and science. Bostrom didn't say we live in a simulation. He said something even more intriguing. He proposed that at least one of these three statements must be true. First, that advanced civilizations tend to go extinct before developing simulation technology. Second, that advanced civilizations have no interest in making simulations of their ancestors. Or third, that we almost certainly live in a computational simulation. Bostrom's reasoning is elegantly simple. If a civilization manages to survive and develop enough technology, it will likely create many simulations of its ancestors for historical, scientific, or entertainment reasons. If this happens, the number of simulated beings would be astronomically greater than the number of real beings. So, statistically, any consciousness that arises would have a much higher chance of being simulated than real. It's like there are 1,000 fake coins for every real coin. If you pick a coin at random, it'll probably be fake. But hold on a sec. Are we talking philosophy or science here? The answer is both. And this is where things get really interesting, because physicists have started finding strange aspects in our universe that make sense if we re in a simulation. The first clue comes from the very structure of reality. Our universe seems to be fundamentally digital. In quantum mechanics, energy isn't continuous. It comes in discrete packets called quanta, like cosmic pixels. It's as if reality has a minimum resolution, exactly what we'd expect in a computational simulation. When you zoom in a lot on a digital image, you eventually see the individual pixels. Similarly, when physicists investigate reality at extremely small scales, they find this fundamental granularity. The Planck length, approximately 10 to the minus 35 meters, represents this smallest possible unit of space. It's as if the universe has pixels smaller than anything we can imagine. A cosmic pixel would be trillions of times smaller than a proton. If you were a character in a video game and could investigate your digital reality, you'd find exactly this fundamental pixelated structure. Another fascinating aspect is that the laws of physics seem optimized for efficient computation. The speed of light acts like a processing limit. Information can't travel faster than that, avoiding synchronization problems that would break a simulation. The quantum uncertainty principle means the universe only needs to calculate details when someone is observing, like a video game that only renders detailed graphics when the player is looking. Think of it this way. When you play an open-world game, the computer doesn't simultaneously process everything happening in the entire world. It focuses its computational resources on what you're seeing and experiencing at that moment. The rest exists only as basic data, being detailed as needed. The quantum universe works in a surprisingly similar way. Particles don't have defined properties until they're re-observed, as if the universe was saving processing power. But perhaps the most intriguing evidence comes from the fundamental constants of physics. There are about 20 numbers that completely define how our universe works. The force of gravity, the electron's charge, the speed of light. If any of these values were slightly different, the universe would be a very different place, possibly incompatible with life. It's as if someone had carefully adjusted the parameters of a simulation to create an interesting and habitable universe. Physicist Max Tegmark from MIT calculates that there are approximately 10 to the 120th possible combinations of these values. The chance of randomly getting a combination that allows complex life is so small, it would be like winning the lottery every day for trillions of years straight. Some scientists argue that this suggests intentional design, as if someone had configured the parameters of a cosmic simulation. Now you must be wondering, if we really live in a simulation, how could we find out? Scientists are developing ingenious tests to investigate this possibility, and some of them are absolutely fascinating. The first method involves looking for glitches in the cosmic matrix. Just as video games sometimes have bugs and inconsistencies, a universal simulation could have detectable flaws. Physicists are looking for small violations in the laws of physics, strange patterns in the cosmic microwave background radiation, or anomalous behaviors at very small or very large scales. A particularly elegant test was proposed by physicist Silas Bean. He suggested that if space has a discrete structure like a three-dimensional grid, this would affect how ultra-high-energy cosmic rays propagate through the universe. It's like looking for evidence of cosmic pixels by analyzing the most energetic particles we observe. So far, we haven't found this evidence, but our technology is still improving. Another test involves looking for computational limits. Every simulation has finite resources. If our simulated universe encountered a computationally very complex problem, we might notice delays, approximations, or strange simplifications. For example, if we tried to simulate many quantum particles interacting simultaneously, the system could crash or produce inconsistent results. Some researchers suggest even more creative experiments. What if we tried to communicate with our simulators? We could create detectable patterns on a large scale, like organizing all of humanity to do something simultaneously that would be obvious to whoever is observing the simulation from outside. It's a crazy idea, but technically possible. There's also the statistical approach. If simulations are common, we should eventually detect evidence of other simulated civilizations, or of civilizations that create simulations. The absence of alien signals, the famous Fermi paradox, could be explained if most of the civilizations we observe are simulated and, therefore, confined to their own digital universes. But here, a test that's gonna make your mind explode. Some scientists propose that we could discover if we re-simulated by trying to overload the simulation. If we started doing extremely complex calculations or creating technologies that demand a lot of computational power, the simulation administrators might need to intervene to prevent the system from crashing. It would be like trying to run too many heavy programs at once on your computer. Eventually, it would crash, or someone would have to close some applications. Theoretical physicist John Wheeler proposed the concept it from bit, the idea that all reality emerges from binary information, zeros and ones. Every particle, every event, every thought can be reduced to bits of information. If this is true, the line between real and simulated becomes much thinner than we imagine. Elon Musk, famous for his ambitious projects, goes even further. He argues that, given the exponential pace of development in video games and virtual reality, we'll soon be able to create simulations indistinguishable from reality. If we can do that, other civilizations probably already have. Musk calculates that the chances of us living in the base reality are billions to one against. But let's take a step back for a moment. Even if we discovered we live in a simulation, would it change anything? Your feelings, relationships, experiences, and dreams would still be real to you. Pain still hurts, joy is still pleasurable, love is still meaningful. If a simulation is perfectly indistinguishable from reality, it is functionally equivalent to reality. In fact, discovering we are simulated could be incredibly exciting. It would mean there's a super advanced civilization somewhere, with technology beyond our wildest dreams. It would mean that consciousness can exist in substrates different from our biological brain. It would mean that life and intelligence are even more extraordinary and enduring phenomena than we imagined. Some philosophers argue that if we are simulated, we have moral obligations to other possible simulated civilizations. If we eventually develop our own simulation technology, we should treat our simulated beings with the same respect we would expect from our creators. It's a cosmic version of the golden rule. Simulate others as you would like to be simulated. The simulation hypothesis also raises profound questions about the nature of consciousness. If we can be conscious in a simulation, it suggests that consciousness is a pattern of information, not something that depends specifically on biological neurons. This has enormous implications for artificial intelligence, mind uploading, and even for the possibility of digital afterlife. Curiously, quantum physics fits perfectly into this scenario. The fact that particles only have defined properties when observed makes perfect sense. If the universe is a simulation that saves computational power by not calculating unnecessary details, quantum entanglement could simply be how the program maintains coherence between different parts of the simulation. Some scientists speculate that we could even discover Easter eggs left by our programmers, hidden messages in the laws of physics, special mathematical constants or patterns in the universe's structure that would only be visible to a sufficiently advanced civilization. Imagine discovering that the value of the cosmological constant, when converted to binary, contains a message saying hello in some alien language. So, cosmic explorers, what have we learned today about this fascinating possibility? First, that the simulation hypothesis isn't just sci-fi. It is a serious proposal based on solid logic and intriguing evidence. Second, that our universe really does have characteristics we'd expect to find in an advanced simulation. And third, that we're developing ingenious ways to test this idea, even if the definitive answer is still beyond our reach. But perhaps the most important lesson is this: whether our reality is simulated or fundamental, it remains extraordinarily rich, beautiful, and meaningful. The fact that we can even contemplate these questions, that we are capable of questioning the nature of reality itself, is a testament to the incredible power of consciousness and human curiosity. We live in an extraordinary era where the boundaries between science and philosophy, between real and simulated, are constantly being redefined. Every new discovery brings us closer to answers for some of the deepest questions we can ask. What is real? What are we? What is our place in the cosmos? Now I want to hear from you, cosmic explorers. If we found out tomorrow that we really live in a simulation, how would that change your perspective on life? Would you be fascinated, scared, or perhaps relieved? Share your thoughts in the comments. This discussion promises to be as interesting as the mystery itself. And since we're talking about fascinating cosmic mysteries, what universe enigma do you want me to talk about in the next video? Leave your suggestions in the comments. Black holes, dark energy, the possibility of extraterrestrial life. Your wishes are orders for this channel. We're on an incredible journey towards 1,000 cosmic explorers. If this video expanded your horizons and made you question the nature of reality, join our crew by clicking subscribe. Like this video if it sparked your cosmic curiosity, and share it with someone else who also loves the mysteries of the universe. In the next video, we'll explore another mystery that challenges our understanding of reality. Get ready for another journey to the frontiers of human knowledge. Until then, keep looking at the stars and questioning everything around you. After all, in a universe where even reality can be an illusion, curiosity is our most reliable compass for navigating cosmic mysteries.